explain why we do this. This is the product rule, and this is what it is, but we use it for differentiating, so we'll use that to differentiate. You might want to put this on top. To differentiate y equals the product of two functions, so u times v. So to differentiate, this is called the product rule because you've got one function of x there and another function of x there. So to differentiate something like y equals u times v, we use this rule. dy dx is u, you write out the first function, times the derivative of the second function, plus, then you write out the second function times the derivative of the first function. Now, I'm going to write that in shorthand. So dy dx will be u times v dash plus v times u dash. So it's the first function times the derivative of the second function plus the second function times the derivative of the first function. That way you've got all bases covered. All right, so that's the rule. To differentiate something like y equals u times x, u times v, sorry, girls, do you know why that and that are the same? Because, ladies, dv dx can be written in shorthand as v dash. du dx can be written as shorthand u dash. Let's say to you, differentiate this. Now, if I was going to differentiate this function here, I wouldn't use the product rule, but I'm going to do it for a really simple function first. Actually, no, I won't. I'll do it for, say, let's say I'll ask you to differentiate this. Okay? I would, so differentiate this. We're going to do it both methods. We're going to expand the whole lot and write it as a normal function, and then we're going to use the product rule. All right? Actually, we'll use the product rule first. So if I've got y equals this function times that one, can you see I've got two different functions in x? This is a function in x, and so's that. Okay? So to use product rule, this is what I do. I say on the side, I go, let u be the first function, which is what? 2x plus 5 squared. And then I write down what u dash is underneath it. So what's u dash? In other words, girls, this is y equals u times v. There's your first function, there's your second function, got it? So u is my first function, so I need to work out u dash, which is what? Bring the 2 to the front, write out the 2x plus 5, drop the power by 1, and then times by the derivative of what's inside, and what do you get? 4 bracket 2x plus 5. So I've done u and u dash. Now, what's v? No, you don't need to write power of 1. And what's v dash? Differentiate x, 1. Differentiate 3 and you get 0. So, y is that. In other words, y is u times v. So dy dx is what? What's the rule? Girls, so you start off with the first one. U, v dash. No, you write the rule out. So, you actually don't normally write that middle line. So girls, you write the question out and then this is what you write. dy dx is u v dash plus v u dash. And you work these out over the side. Alright? So you go u dash, v dash. That's not hard. You've just been doing that for the last 2 exercises. All you've got to do is write down the first function, differentiate it on the side. Do all your messy working out on the side. Do not start doing it all in here, because you'll end up with a big mess. All right? So, you know you've got two functions. Start off by writing u is that, u dash is that, v is that, v dash is that. Then you write out your rule. dy dx is u v dash plus v u dash. And now what do? We just substitute. What's u? Times v dash is 1 plus what's v? And what's u dash? 4 bracket 2x plus 5. I'm really squashed. Can you see it? I'll make it bigger. Sorry, I'm running out of room. I'll move over here. I'm just going to write that line out again. You don't have to, so that you can see it clearly. Plus, what have I got here? I've got x plus 3 times 4. I'm going to put the 4 first. X plus 3, 2x plus 5. Now, girls, The thing with product rule is you have to factorize. How many terms do I have? Terms are separated by pluses and minuses, not with multiplication symbols. Two terms. My first term, did I drop that red or is that yours? I did have a red. All right. The first term is here. The second term is all of that. Can you see that? They're two terms. They're not four terms, not 1, 2, 3, 4. They're multiplied together. You don't tell me that 2 times 3, which is 6, is 2 plus 3. They're not two separate terms. If things are multiplied or divided by each other, they're one term. So girls, I've got two terms. You have to factorize. What's the common factor? One lot of 2x plus 5 is the common factor. Bring it to the front. So if I pull out a 2x plus 5 from here, what am I left with? 2x plus 5, one of those, plus 4 bracket x plus 3, which is 2x plus 5 was the common factor. Now I'm going to expand this. 2x plus 5 plus 12, good. So I've got 2x plus 5 bracket 6x plus 17. Okay? And that's that. Now see this question, I probably wouldn't have done it this way. I'll show you because it's just a squared. Anything over a squared, girls, what I'm just going to do, you would leave your answer as that. But if I want to expand it, what do I get? 12x squared plus 34x plus 30x is plus 64x plus 17 times 5, 85. Now, you would leave it like this, all right? But that's what that is. Now, what we're going to do, we're going to prove that this works. I'm going to take the original function. Now, you would never normally do this. The original question was this. Y equals 2x plus 5 squared, bracket x plus 3. I'm going to just expand that. You know, a few lessons ago, if you had a question like this, what you did was expand that. What do you get if you expand that? 4x squared plus 2 times that, 20x plus 25, bracket x plus 3. Then you expanded it. This is what you did, I think, back in exercise 8.4 or something, or 8.5. Then I just want to make sure we get the same answer as what we had. Then you expand and you get 4x cubed plus, well, all right, we're going to go the first one times both, so plus 12x squared plus 20x squared plus 60x plus 25x plus, you'll never do this again. I'm just doing this to show you. I've got a problem. Why don't I have a cube? Oh, yeah, that's okay. 4x cubed plus 32x squared plus 85x plus 75. Now, that's what y is. So dy dx is, this is before you learnt the product rule, this is what you would have done. You would have expanded. Imagine if that's cube or power of 4. You'd be there forever. But 12x squared plus 64x plus 85. Let's see our answer from the other part. Here's your other answer. Here's our answer from what I just did on the sheet before. The same. Can you see it? Girls, from the other page with the product rule, ladies, I just got this from using the product rule, same answer. All right? No. Now, let's do some more product rule questions. I'll just do some. Product rule? No, well, girls, if I ask you, you have to use product rule. Now, exercise 8.9, we're going to do some questions. Actually, I better do this example. I'm going to do example 3 from your book, which is 3, differentiate this. Now, this is where they start getting tricky. This is where you cannot expand. You cannot do that. If y is that, find dy dx. Differentiate. All right, stop. Before you start. U, no. What does u? So we start. So girls, yep, we will in a minute. So girls, isn't it u v dash plus v u dash? Isn't that the rule? So girls, that's what y is. To differentiate, it's u v dash plus v u dash. So over here, I'm going to work out what's u and u dash. What's v? The square root of 5 minus 2x, which we don't like to write as that, to the half. So you do all this working out on the side. Girls, I've got a small piece of paper. That's why mine's... So v dash is, bring the half to the front, 5 minus 2x to the negative a half times differentiate what's inside. Now, the half times negative 2 is what? Negative 1. 5 minus 2x to the negative a half. What am I going to do with this negative a half? Actually, just leave it. Leave it. Leave it there. Don't put it as square roots. Don't do anything when you're doing product rule. Just leave it as is. Don't simplify it. Because we have to factorize. So we just stop there and we've got everything there. I don't know if I'm going to fit the rest of this over here. So I'll have to move down.
That's why I like writing stuff on the side.
Well, if you're using, girls, you're going to have to start using 2 columns, or you just do that all and then work underneath. If you're using 2 columns, just write that and then write the next bit underneath. As we get into 3 unit and some harder stuff, you can't use 2 columns anymore. You're going to have to start just going across the page, girls. All right? You're not going to have the room. So dy dx is, I know the formula. Let's do the substitution. What's u? U v dash. So it's times negative 1, bracket, 5 minus 2x to the negative a half, plus, that's a times there, by the way, it's not a minus, plus, what's v? What's v? U dash. Girls, u v dash plus v u dash. Now, girls, I've got 2 terms. That's one term, that's the other term. Tell me what you've got as a common factor. It's 5 minus 2x. Don't you always pull out the smaller factor? What's smaller, the negative a half or the positive a half? The negative half is smaller. So you pull out the 5 minus 2x to the negative a half from each. Because negative a half is smaller than positive a half. By how much? By 1. So now, once I pull that out, what am I left with? 3x minus 4 times, it's negative bracket 3x minus 4 because it's 3x minus 4 times negative 1. So it's negative 3x minus 4. Now, in the second term, I've just got to go up.
What do we do with the half?
Plus, no. Girls, if you've got powers, negative a half, if I add 1 to that power, don't I get positive a half? So, just watch. It's just to the 1 and I'll show you why. I'll show you why. That times that clearly gives you that. 5 minus 2x to the negative half times 5 minus 2x to the 1, the bases are the same. Negative a half plus 1 is positive a half. Do you see that? Girls, watching this again. I've pulled out the negative a half. If these were normal numbers like 2 and 3, you would have put squared and made this one 1. But the difference between negative a half and positive a half is if you're adding 1. Bases are the same, add the indices. Do you get that or not? Maybe I'll do one without the halves. I should have done one without halves first, because you're going to find that confusing. So what have we got? To the negative a half. Expand this now. What do you got? Negative 3x plus 4 plus 15 minus 6x. So it's 5, sorry.
Did we change it back to the square root?
Yeah, we'll do it in a minute. 5 minus 2x to the negative a half.
Minus 9
Let's do the positive term first. 19 minus 9x. Now, let's put that on the denominator. 19 minus 9x over,
Square root of 5 minus 2.
yeah, over the square root of 5 minus 2x, or over the square root of 5 minus 2x to the half, which is the square root of 5 minus 2x. Now, I know you're going to find that a bit tricky. We're going to do a couple more. I'm going to do, girls, I know, is this where you're stuck? Girls, no, because if the bases are the same, what's negative a half plus 1? Positive a half. Girls, can I do one more, please? Well, you go and come and watch the rest of the video later.
Yeah. And we're saying back to the what's the homework for this part?
All right, the homework will be exercise 8.9. You can do every second, well, how much practice do you want? You want a lot of practice, you do it all.
Are we doing a lot?
I'll do,
Do we need the practice?
yeah, you need the you need the practice with this. So you're doing it all. I'll do some more questions from question 1 now. Girls, those that stay now, I'm doing some more examples. Or do you just want me to video it? Point 9, I'm going to do a few more examples. Question, I'm going to do ones with normal powers. Question, question No, question H. Y equals 3x to the 4 times 4 minus x cubed. 1H. And I'm then going to do 1K as well. All right, let's go. You have to differentiate that. So, dy dx will be u times v dash plus v times u dash. Let's just work out what each one is. What's u? Do you want to try it on your own? What's u? X to the 4. U is your first function. U dashed is? Yeah, it's 3 times 4x cubed, which is 12x cubed. V is 4 minus x cubed. V dashed is, bring the 3 to the front, 4 minus x squared times, differentiate what's inside, times negative 1. We okay? Rosa? Which is negative 3, bracket, 4 minus x squared. Okay, so we're set up. Our u dash, v dash is all done. Now we substitute. So dy dx equals u times v dash is this. So it's times negative 3, 4 minus x all squared, plus v is that, and u dash is 12x cubed. Now with this one, girls, there's more than, this is a time symbol here, by the way. So again, you're only going to have 2 terms. There's your first one and there's your second one, because terms are separated by addition or subtraction signs, not by multiplication symbols. That makes one term. Now look at the x's. Actually, look at the numbers first. I've got 9 and 12 for numbers, or negative 9 and 12. What's the highest common factor of 9 and 12? 3. So 3 comes out. Then look at the x's. X to the power of 4 and x cubed. What's the highest common factor? X cubed is the next highest. No, x to the 4 and x cubed, just the normal x's, not the brackets. Now look at the brackets with the 4 minus x's. What is the highest common factor? X minus 4 squared, because there's 2 of them there and 3 of them here. Girls, can we see that?
Yeah.
Bracket. Now, you've got to see what you pulled out. I pulled out a 3, I've still got a minus 3 left. I pulled out x cubed, what have I still got left? Another x. And I did pull out all of the 4 minus x squared, okay? Plus, I've pulled out 3. What do I still need to pull out? Like, I've pulled out the 3 from the 12. I've still got 4 left. I've pulled out x cubed. That's okay. They're all gone. But I pulled out only 4 minus x all squared. So what do I still write? I've still got 1 4 minus x left. Do you see that, girls? Yeah. Girls, I've got 2 terms. I pulled out a 3. You look at the numbers, pull out a 3. Look at the x to the power of 4 and the x to the power of 3, pull out x cubed. Look at the 4 minus x to the power of. 4 minus x squared is the smallest one. So what's left over if all of this is pulled out from the first term? There's still a negative 3 and another x. That was all pulled out. Plus, second term. What's left over? A 4. The x cubes are all gone. And there's one lot of the 4 minus x. You can put a 1 there, but you don't need it. So we've got 3x cubed, bracket, 4 minus x squared, expanding this, minus 3x plus, that's to the power of 1, so you don't need it, plus what? 16 minus 4x, which is 3x cubed, bracket, 4 minus x squared. How do you simplify that? Give me the positive. 16 minus 7x. Yep, that's it. And it can be written in that order, that's fine. Girls, we can practice. I want to do another one. Let's do J. All right, why don't you try this one on your own? Differentiate this. All right, I think we'll do the U's here, U dash, and the V, V dash.
Is that 3 or 5?
That's a 5 on the end.
No, that's
This is a 3. So we've got y equals x cubed plus 5x squared minus 3 times x squared plus 1 all to the power of 5. We need U, U dash, V, V dash. Everyone have a go, please. That's what U is, x cubed plus 5x squared minus 3. Then you have to do U dash. Jane, what's U dash?
3x squared plus 10x.
And 0. If you differentiate a constant, you get 0. Okay? V is x squared plus 1 to the power of 5. What was the rule we learnt today? Bring the 5 to the front. X squared plus 1 to the power of 4 times, differentiate what's inside, times 2x. Differentiate x squared, you get 2x. Now, let's simplify this. 5 times 2x is 10x, bracket, x squared plus 1 to the power of 4. So, sorry, I'm off screen. So, we've done U, U dash, and we've done V and V dash. So, therefore, dy dx is U times V dash plus V times U dash. Substituting in. Yeah. X cubed plus 5x squared minus 3. V dashed is, put a dot, 10x, bracket, x squared plus 1 to the power of 4 plus V is x squared plus 1 to the power of 5. And U dash is, I need another bracket because it's more than one thing, 3x squared plus 10x. Now, you know what I didn't do and I should have done? Girls, I need to do something here. Come back here. We've got a problem. Girls, the reason I've just stopped the video here and I've gone back here, and if I write 3x squared plus 10x here, what we had there, I actually have an x here as a factor in the first term. So I actually can have an x as a factor in the second one. So what I'm doing, I've gone back to my u dash because it's not fully factorized, my u dash. And it's really x bracket 3x plus 10. So I'm going to put that in here now. So times x bracket 3x plus 10, close bracket. Now, one sec. Got to be careful with this. Are we ready? So we've got equals. I've got two terms. First term, second term. Look at each one. There are no numbers that can be pulled out from what I can see. What about any x's? There is an x. There's just a normal x in each one. Then we've got an x squared plus 1 to the power of what?
4.
And nothing else. So let's just see what we've got left. We've pulled out an x and an x squared plus 1 to the power of 4 from the first term. So we're therefore left with 10. Yes? What else? Oh, sorry, girls. I've just pulled out the x and the x squared plus 1 to the power of 4. So I'm left with all of this. 10 bracket x cubed plus 5x squared minus 3 plus, because I do have a plus here, the x was pulled out and the x squared plus 1 to the power of 4 is pulled out. So how many left? X squared plus 1 to the power of 1, which is just x squared plus 1, bracket, because the x has been pulled out, 3x plus 10. Girls, I think we need to expand this. Okay? Girls? Bracket, x squared plus 1 to the power of 4. Now, we'll expand this, and we're going to expand that, all right? We've got 10x cubed plus, what else? 50x squared minus 30. Now, to save yourself a line, what have we got here? We've got 3x cubed plus 10x squared plus 3x plus 10. So, girls, they expect it fully done. So this is why I'm going to be getting you to do each one of these questions. It's very good practice. So it's x bracket x squared plus 1 to the power of 4. Now let's collect like terms. 10x cubed and 3x cubed is 13x cubed. Let's look at the x squareds. Plus 60x squared. Any normal x's? 3x. Minus 30 plus 10 is minus 20. And we're done. It's a lot of work. So girls, a fair bit of work. So what you'll be doing is, I want every question done because it's really good practice. So we'll be doing all of exercise 8.9. It's going to take you a bit of time, but or we can just actually, no, why don't we just do every second? We'll do every second in 8.9, question 1. Oh wait, do you have all that down? So this is what we'll do, because we'll make sure we do all the worded problems. Exercise 8.9, question 1. I'll just choose some of them. Anyone need this sheet? Come and take it. What do we do? Question 1D. Don't want to do them all. Do G. No, not G. 1D and F. Did I do H? Yes. I did J, didn't I?
Yeah.
I, K. Don't do L because L is quotient rule and I don't want you doing it. So it's just question 1D, F, I and K, because that's not clear. And then you can do question 2, the gradient of the tangent. You don't need to do 5. 2. 3, just for notation. You know what? Don't do 2. Do 3, 4, 6. Yeah, 6 to 9. So it's 1 D, F, I, K, and then 3, 4, and 6 through to 9. Okay? That's it. Tomorrow is quotient rule. Exercise 8.10.
Miss Claudine, I'm doing the maths test tomorrow.
Oh, yes. Oh.